In a staggering series of breakthroughs culminating in late 2025, the concept of warp drive has shifted from science fiction to a rigorous and terrifying field of physical study. While new modular designs and sublight alternatives offer a path to the stars, scientists warn that the very physics allowing us to cross light years could inadvertently create a weapon capable of vaporizing entire star systems. The dream of interstellar travel was ignited in 1994 when physicist Miguel Alcubierre proposed a way to bypass the cosmic speed limit. Instead of moving a ship through space, he suggested moving space itself, compressing the vacuum in front of the vessel and expanding it behind. This warp bubble allows a ship to sit stationary while the fabric of reality carries it forward like a cosmic surfboard. Recent research from the White Team and applied physics has refined this vision, moving from theoretical math to laboratory-scale spacetime distortions. However, the path to the stars is paved with extreme physical hurdles. Initial calculations suggested that powering such a bubble would require the mass-energy equivalent of the planet Jupiter. While newer designs have optimized this requirement, they often rely on negative energy, an exotic state of matter rarely seen outside of nanometer-scale laboratory experiments like the Casimir effect. In 2024, researchers proposed a version using positive energy, though it limits the ship to sublight speeds. Even at 90% of the speed of light, a trip to Proxima Centauri would take less than 5 years, a timeline well within a human lifespan. Despite this progress, the deceleration problem remains a nightmare for astronomers. Physics dictates that as a warp bubble travels, it gathers high-energy particles from the vacuum of space. When the ship arrives at its destination and stops, these particles are released in a concentrated blast of gamma radiation equivalent to a stellar-scale hydrogen bomb. This stellar-killing side effect means that any ship arriving at a populated planet could accidentally incinerate its inhabitants before the crew even disembarks. Furthermore, the one-way ticket flaw suggests that once a warp bubble is active, the crew loses all causal contact with the outside universe. They cannot steer, they cannot signal, and they may be incinerated by Hawking radiation generated at the bubble's edge. This has led some theorists to suggest that warp technology might be the great filter of the universe, a developmental hurdle so dangerous that every civilization that discovers it eventually destroys itself. As of 2026, the focus has shifted toward detecting these drives in the wild. Scientists believe that the collapse of a warp bubble would create unique gravitational wave signatures. If our detectors pick up these specific ripples among the stars, we will finally have proof that we are not alone. The only question remains whether those signals represent a leap toward galactic exploration or the final echoes of a civilization that failed to master its own power.